Hello, welcome to my class on isomerism. Isomerism. Actually, the name isomerism is said to be derived from the Greek words. In that, iso means equal, mer means part. Actually, this isomerism definition, how we can give, we will see. What is the exact definition which was given to us is the existence of different substances with same molecular formula is called isomerism. The existence of different substances with same molecular formula. The existence of different substances with the same molecular formula, which is called as isomerism, which is the definition of isomerism. Actually, different substances that have said to be same molecular formula in this case are called as isomers. What are isomers? This phenomena is called as isomerism, and the substances existed with the same molecular formula are called as isomers. And these isomers exist different physical and chemical properties. So what is the importance of these isomers is they have different chemical properties, they have different physical properties, they have different properties. Usually in chemistry we will talk about the properties. Properties nothing but chemical property as well as physical property. Okay. Now we will see an example. That means one example if we see, we will get an idea. What is the exact name called N-butyl alcohol? N-butyl alcohol. N-butyl alcohol. N-butyl alcohol is actually isomer with diethyl ether. Diethyl ether. What is the reason behind that one is these two substances are said to be having same molecular formula. What is the molecular formula of N-butyl alcohol is C4H10O, and diethyl ether molecular formula is also C4H10O. Now, from these two names of different compounds with same molecular formula, we can understand the definition. What is the definition? The existence of different substances with the same molecular formula. So molecular formula is same, C4H10O, C4H10O. And these two we can call isomers, but the physical properties are not same. Chemical properties are also not same. So, physical and chemical properties of alcohols are different. Physical and chemical properties of ethers are different. That means only butyl alcohol, if you take an example, butyl alcohol, if you treat with sodium metal, it releases hydrogen gas. but ether does not release hydrogen gas with sodium metal. What is that meaning of that simple experiment in the chemical lab? Indicates that chemical property of ethyl alcohol with sodium giving a result hydrogen gas which is not coming when you take diethyl ether in the place of ethyl alcohol, butyl alcohol. So butyl alcohol chemical property is different with that when compared with that chemical property of diethyl ether. That is one simple example to tell about what is the difference in properties. What is difference in the properties? And such type of compounds we can call isomers. Actually, N-butyl alcohol is nothing but straight chain alcohol, that is CH3, CH2, CH2, OH. So if you take the formula, this one, this is 4 carbons and 10 hydrogens and 1 oxygen is present for molecular formula is matching with this one. And diethyl ether if you take, it is CH3, CH2O, CH2, CH3. This is diethyl ether. Here also 4 carbons and 10 hydrogens and 1 oxygen is present, which indicates that molecular formula is different and physical and chemical properties are different and the functional groups names also different. That is why we have taken this a simple example to understand what is isomerism. Once again I will revise what is isomerism definition. Isomerism is nothing but the existence of different substances with the same molecular formula is called as isomerism. And that different substances that have the same molecular formula we will call isomers. Okay, what are isomers? What is isomerism? We have observed. Isomerism is a phenomena and the substance is called as isomer. Now we start telling about some differences, that is isomerism classification. If you see, what is isomerism classification, if you see, the one simple, this is a simple classification I am talking about, simple classification. In this simple classification, the one will call it as a structural isomerism. Structural isomerism. The other one we will call it as stereo isomerism. Stereo isomerism. One is called as structural isomerism, another one is called as stereo isomerism. In the simple classification, structural isomerism, the name itself we are stressing structural. Structural means they have different structures. They are called as structural isomers and the phenomena is called as structural isomerism. So what is structural isomerism? Isomers that have different structures are called as structural isomers and that phenomena is called as structural isomerism. If you take the same example here, N-butyl alcohol, diethyl ether, you take these same examples, then what you can understand from this definition of structural isomerism is in ethyl alcohol and in diethyl ether, the atoms are connected. That means connectivity of the atoms is different. That means different connectivities are said to be existed in the same molecular formula of this alcohol and ether. That's why they have different properties and such compounds with same molecular formula now we are calling them different structures and they are called as structural isomers. So with this example only we can define what is structural isomerism. Coming to the second simple classification we are observing on the board, that is stereo isomerism. Stereo isomerism. Stereo means in space, three-dimensional ways manner. That means isomers that have here also structure is said to be not like the previous one. Here structure is different. Here structure is same structure but different in the spatial arrangements of atoms or groups of attached to carbon. So here structures are different. Here structure is same but the spatial arrangement of atoms attached to the carbon are different. This is three-dimensional manner of observing the isomerism. That means stereo means in space. Okay. And we will talk in detail about the structural isomerism. In that one, if you take a simple example, lactic acid that is having two forms. One form is having different arrangement with another form of atoms in space around one carbon. That is why stereoisomerism is a separate discussion in our isomerism concept. We will carry forward the information. We will continue that one, elaborate that one in the next sessions. Okay. For example, if you want simple idea about this one to discuss, I will give you a formula like this one for lactic acid, carbon, hydrogen. I have given dotted line. Don't worry about that one. The another one I have given thick line is a bond only. This is bond only. Here I am writing one functional group. Here I am writing one alkyl methyl group. And this one only I am writing, just shifting these bonds over the second carbon here. Here I am writing this hydrogen this side and OH also this side. This is OH. Now we observe these two. That means in this example I am going to just tell one thing. This is lactic acid. It is having two forms, but both are having the same structure but differ in the arrangement of methyl group, hydrogen, OH and carboxylic acids on C2 carbon, second carbon. This is a second carbon. So the difference, what is the difference is rotation. They differ in the rotating plane polarized light. That means plane of polarized light. If you pass the light, that substances definitely will rotate the light in different directions. It rotates towards the right side. One rotates towards the right side. One rotates towards the left side. So other one rotates the plane of polarized lights in the left side. That's why these two we will call, they are stereoisomers. Not only that one, not only this, only one example. For our understanding, general understanding, small idea, in this session we have given this example. And another thing is there in the stereoisomerism, we have double bonded compounds are there, alkanes. If you take butene, then in that also is that butene is said to be existed in two different forms, arrangements of atoms and groups around the double bond is different, but the form structure is same only. Okay, so if you take that example, the double bonded carbon atoms are there, these two. Butene is nothing but this one, and in this we will be having hydrogen methyl group. See, this we are going to write now. Here, same side of the double bond we will write the methyl groups. Same side of the double bond we will write the hydrogen, same side. when it is changed in the opposite sides, then this structure is different. Physical properties are different for these two. That's why butene is said to be existing is also in two forms, differing in the arrangement of atoms and groups around double bonded attached carbon atoms. So observing these things, we got an idea that what is the introduction of isomerism. Introduction of isomerism, we have stated a definition of isomerism and substances which are exhibiting isomerism, and example, simple examples like alcohol ether we have taken. After that, a very simple classification of isomerism into structural and stereoisomerism with one example we have observed. Okay, I hope you got an idea in this small session about what is isomerism. When you start elaborating isomerism, structural isomerism, that may goes in different classification, that is of different types. Okay, that we will see now. So what we are going to talk about, this one is structural isomers. We can also call them as constitutional isomers. Structural isomers. Actually, they are classified into different kinds. What are those different kinds? We are going to write now. Few. One we will call, in a carbon chain, if you observe the difference on the compounds with same molecular formula, isomers having different carbon chains, different shapes of the carbon chains. Such isomers are called as chain isomers. The phenomena is called a chain isomerism. When we observe the position of any group or group of atoms or any functional group is different, then that is called as position isomerism. The structural isomerism is called as position isomerism. And when we talk about any kind of functional group is changing in different carbons with same molecular formula, then that is called as functional isomerism. Functional isomerism. That means over the carbon chain, different kinds of locations, the functional group is changing. Not only that one, the functional group is completely different. Like we observed, the alcohol and ether. And another one we will call it as metamerism. In the same functional group, we will see different kinds of attachments of alkyl groups. That is called as metamerism. The other one we will call it as finally, that is tautomerism. So chain isomers are there, position isomers are there, functional isomers are there, metamers are there, tautomers are there. So in this, among these we have tautomers are said to be different from all other isomers because tautomers are said to be interconvertible and also exist at dynamic equilibrium. That's why tautomerism is quite different from the other kinds of isomerisms we have. Okay. So now we are observing structural isomers of classification. There are different kinds of structural isomers are there on the board. We wrote that is the first one is chain isomers, second one is the position isomers, third one is the functional isomers, fourth one is metamers, fifth one is tautomers. When you start talking about chain isomers, what is the meaning of chain isomerism is nothing but in the name itself it is stressed. That means they have different carbon skeletons. Particularly, they have different parent chains also there. Among such a type of isomers possessing a functional group, the functional group present in them is same and the position of their parent chain also is same. What is the meaning of this one? We will see with an example. Suppose I am talking about butane, that is C4H10, N-butane. If you are writing about N-butane, how you will write this one is nothing but is a straight chain you will write. This is CH3, CH2, CH2, CH3. When you say the name is different, that is isobutane. Isobutane, definitely the parent chain is not the same. We are going to select a carbon chain like this, 3 carbons chain, CH, CH3 branch we will see. First one we will call N-butane, but second one common name is isobutane. IUPAC name is 2-methyl propane. It is 2-methyl propane. Now you understand what is chain isomerism. Likewise, we can write the pentane, we can write even hexane, double bonded compounds also. Suppose I am going to take an example, that is C5H10. It is not pentane, it is pentene. We are going to see one thing, that is pentene is nothing but double bonded compound alkane. The double bond you can write or the carbon chain like this. Suppose you are going to write the double bond here. It is CH2, CH, CH2, CH2, CH3. Now you see there are 10 hydrogens, 5 carbons. I can call this one as nothing but pent1-ene or 1-pentene. Pent1-ene. I just want to change the double bond location onto the other location, other place, or I can also change the carbon chain in a different manner. I want to break this CH3 and put CH3 here. Okay. Then that is also possible. How we can write CC? That is nothing but CH3, CH, CH3, CH, double bond CH3. See, here this is CH2, right? Now, if you see this one, this on the second carbon, we have methyl is there. On the third carbon we have methyl is there. On the first carbon we have ene is there. So we can call this one as 3-methyl but1-ene. 3-methyl but1-ene. But the molecular formula is same. So you can also change the double bond other location, or you can completely change the parent chain. That means the number of carbons in the parent chain also got changed here in this example. Likewise, several examples you can take to understand chain isomerism. Likewise, triple bond you can take, or else you can take any kind of the functional group also you can take. Suppose C5H12O, I am going to take a formula to conclude this chain isomerism. I will continue in the next session also. One I can write as a 5 carbon chain, another I can write as a 4 carbon chain like this only. So how we can write that is CH3, CH2, CH2, CH2. So here we have finished around 9 hydrogens and 4 carbons. The next one is nothing but I am going to write CH2OH. So I continued writing carbon, 5 carbons and attached to one functional group OH, alcohol. I can call this is amyl alcohol. Amyl alcohol, or IUPAC we want to stress, then it is pentane 1-ol. Pentane 1-ol. Like the above example, we can make the 4 carbon chain and we can also write this entire functional group as it is with 4 carbon chain, break this CH3 and putting here that one. Okay, I will show that one how. This is CH3, CH, here I am going to write CH3, this is CH2. See, we have finished 9 carbons here. We have finished 9 hydrogens and 4 carbons. Another carbon here I am writing, OH I am writing here. So OH attached carbon is important one for us. So we can write this is 3-methyl pentane 1-ol. 3-methyl pentane 1-ol. It is called as isoamyl alcohol. Another one is called as, general name is isoamyl alcohol. Isoamyl alcohol. And taking different examples for the structural isomers and the classification will be continued in the next session. Okay, I hope you understand this session, whatever the examples I have shown to you. So you can just revise this one and to understand the isomerism introduction. Okay, have a nice day. Thank you.